ओके हेलो एवरीवन। तो आज हम डिस्कस करेंगे यूनिफॉर्म कॉन्टिन्यूटी का क्वेश्चन। बहुत ही इंपॉर्टेंट क्वेश्चन है। इस क्वेश्चन के हेल्प से हम बहुत सारे क्वेश्चन अटेम्प्ट कर सकते हैं जो कि दिखने में बहुत टफ होगा, वो हम लास्ट में डिस्कस करेंगे। इसके हेल्प से हम कैसे प्रॉब्लम सॉल्व कर सकते हैं। तो फर्स्ट ऑफ ऑल ये एक लेमा है। ओके, तो ये लेमा क्या कह रहा है कि इफ R2 एक यूनिफॉर्मली कॉन्टिन्यूअस फंक्शन, देन देयर एग्जिस्ट a, b greater 0 such that mod of f of x is strictly less than a mod x plus b। और हम क्या कह सकते हैं, फॉर सम सफिशिएंटली लार्ज x mod of f of x by x strictly less than k। ओके, फॉर सम कांस्टेंट k, राइट। इसका मतलब क्या हो रहा है कि अगर एक यूनिफॉर्मली कॉन्टिन्यूअस हो जाए तो फॉर सम लार्ज x f of x का जो ग्रोथ है वो mod of f of x का जो ग्रोथ है वो mod x के समान हो जाएगा फॉर सम लार्ज x। ओके, ये थ्योरी में ही कहना चाह रहा है, ठीक है। तो हम इसको प्रूफ कैसे करेंगे? ये प्रूफ करना थोड़ा मतलब उतना आसान नहीं है पर आसानी है। तो थोड़ा ये टेक्निकल है इसका प्रूफ। ओके, थोड़ा टेक्निकल प्रूफ है। ओके, तो हम प्रूफ की तरफ बढ़ते हैं। प्रूफ, ओके, गिवन दैट f is uniformly continuous on R, right? So what is the definition of uniformly continuous? So for every epsilon greater 0 there exists delta greater 0 doesn't depend on any point, right? This delta for uniformly continuous, this delta doesn't depend any point on doesn't depend on point, right? Is it's only depend on this epsilon. Okay, you gave me epsilon, I will give you delta. This delta is independent of choice of x. Okay, so for every epsilon greater 0 there exists delta such that whenever mod of x minus y is less than less than delta, we have mod of f of x minus f of y is less than epsilon for all x comma y belongs to where R, right? This will hold. Okay, okay, now take epsilon equals to 1, right? Then what we get, mod of f of x minus f of y is less than 1, right? Okay, now our aim is to partition the interval 0 to x. Okay, that is our is to goal is to the line goal is to partition the line 0 to x for x belongs to R. Okay, such that what, such that each subinterval has length at most delta, that is less or equals to delta. Okay, that is, this is our 0. Let's say x is positive here. Okay, maybe x is negative, but without loss of generality I am taking now x is positive. Okay, so I subdivide this interval like this. Okay, some finite limit. Okay, and how I divide this 0 to x, ऐसे डिवाइड करूंगा मैं ताकि हर एक पोर्शन का, हर एक सब इंटरवल का लेंथ लेस और इक्वल्स टू डेल्टा हो। ओके, लेस और इक्वल्स टू डेल्टा, लेस और इक्वल्स टू डेल्टा। ओके, हर एक के लिए। तो मैं इस क्यों क्यों कर रहा हूँ, मैं हर एक सब इंटरवल का लेंथ लेस और इक्वल्स टू डेल्टा मैं क्यों चाह रहा हूँ? मैं चाह रहा हूँ इसलिए कि हर एक सब इंटरवल में मैं ये सेम डेल्टा के ऊपर, ये सेम डेल्टा को लेके मैं यूनिफॉर्म कॉन्टिन्यूटी को अप्लाई कर पाऊँ। ओके, ये जो डेल्टा हमें मिला इस एप्सिलॉन के लिए, इस डेल इसके ये एप्सिलॉन के लिए जो ये डेल्टा मिला, इस डेल्टा को लेके मैं काम करूंगा। ओके, ताकि मैं हर एक इंटरवल के ऊपर इसी डेल्टा को अप्लाई कर पाऊँ, इस डेल्टा के लिए यूनिफॉर्म कॉन्टिन्यूटी अप्लाई कर पाऊँ। ओके, ओके, चलो देखते हैं तो कैसे करेंगे। ओके, so for every x belongs to R, there exists k belongs to natural number such that we can write this, right? Mod x by delta is less or equals to k and less than mod x by delta plus 1. Okay, for every real number x we can have a natural number, say k, such that this happens. Okay, mod of x by delta is less or equals to k and less than mod x by delta plus 1. Think how? Think why? Okay. Okay. Now define xi. Define xi as how we can define xi? Okay. Okay. Mod x I by k, where I equals to 0, 1, 2. Okay. So we get a sequence, right? For each I, we defined xi. Okay. How? Mod x into I by k. Okay. Okay. Now check xi minus 1. Is it less or equals to delta? Is it less or equals to delta? Is the modulus value less or equals to delta? Let's check it. Okay. What is this xi? How I defined? Mod of x into I by k, and this is mod of x into I minus 1 by k, right? And this is equals to what? Mod of x by k, that is mod x by k, that is less or equals to delta, right? From here, that is less or equals to delta, right? From here. Okay. So each sub interval, that is for all I equals to 0, 1, 2 dot dot dot, has length less or equals to delta. Okay. Now 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 what we want? Now we want to apply uniform continuity on each subinterval, right? Okay. Okay. So let's apply f of x minus f of 0. Okay. Okay, first of all, without loss of generality, now take x is greater than 0. Okay. This in the similar manner you can do it for x less than 0, right? Okay. So f of x minus f of 0, we can write it like this, right? 1 second. Okay. Okay, before that, take x naught equals to 0 and xk equals to x. Okay, take it x naught equals to 0 and xk equals to x. That is, we have this 0 and this x, and we partition the line 0 to x, right? So it is x1, it is x2, it is x3, and so on. It is xk and it is x naught. Okay. Okay, so we can add and subtract terms here, right? So this I can write as this is what? This is x, right? So I can write it here xk minus f of xk minus 1, right? Plus f of xk minus 1 plus f of xk minus 2 minus f of xk minus 2 plus, proceeding similar manner, we get f of x1 minus f of x0, right? Okay. Now take the modulus f of 0. Okay. Now this is less or equals to, by the triangular inequality, f of x minus f of okay, plus f of xk minus 1 f of xk minus 2, okay, plus dot 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 mod of f of x1 minus f of x0. Okay. Now you clearly see that each subinterval, we see that each subinterval xk minus 1 has distance less or equals to delta, right? So when whenever this distance is less or equals to delta, we have this distance is what, less than, strictly less than epsilon, right? You understand, na? This is the definition of uniform continuity. Okay, so we can apply here that, so I take epsilon equals to 1, right? Now take epsilon equals to 1. Okay, so this value is strictly less than 1, this value is also strictly less than 1, this value is also strictly less than 1, and dot dot dot, this value is also strictly less than 1. Okay, so what we get mod of f of x minus f of 0 is strictly less than, how many times we add here and subtract here, so how many one, k, right? K. Okay, this is k times, right? Okay. Okay, now I can write it. I can write it. I can write it or not, because mod of f of x minus f of 0 plus mod of f of 0 is less than k plus mod of f of 0, right? And that is what, mod of f of x is less than k plus mod of f of 0. Okay, so this k is what, this k, recall, this k is strictly less than x by, sorry, x by delta plus 1 and greater equals to x by delta, greater equals to x by delta, right? So apply this k is strictly less than x by delta plus 1. So what can I write here? This is less than, this is less than x, right, plus, right, plus of 0 plus 1, right? Okay, okay, okay. Now take a modulus also, not a, oh sorry, we have the modulus already, right? Let's just see it. Yes, we have the modulus, right? Okay, so till now हमें ये सब यहाँ तक मिला. ओके, तो यहाँ से डायरेक्टली विजिबल हो रहा है, जो हमें चाहिए था वो हमें मिल गया ऑलरेडी. क्या दिखाई दे रहा है? हमें चाहिए क्या था? mod of f of x is less than some a and b is strictly greater 0, and mod of f of x is less than a times mod of x plus b. Now this is capital B, right? Okay, plus b. Okay, तो क्या तुम्हें दिखाई दे रहा है कि हमें मिल गया ऑलरेडी ये चीज? mod of f of x is less than a into x plus b, where b is f of 0 mod of f of 0 plus 1 and a is 1 by delta, and both are positive, right? This is mod value plus 1, this is also positive, strictly greater 0, and this is 1 by delta is also strictly greater 0, right? So our result is proved for x strictly greater 0. Now you have to do the similar thing, right? Without loss of generality, I take x is strictly greater 0. Now similarly do for x is less than 0. What you have to do, just take x equals to some minus t where t is greater 0. Now do the same thing. There exists some k such that k is strictly less than t by delta plus 1 and greater equal to t by delta. Okay, and define the sequence like xi equals to minus I by k into t. Okay, why I take minus I by k? Because minus I by kt, because this minus and t will will give me this x. Okay, 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 okay. Now proceed similar manner, you will get this inequality. Okay, so we proved this theorem. This is a very important theorem. Now we see an application of this theorem. Okay, okay. Now a question. Now question. that there exists a uniformly continuous function f from open 0 comma infinity to open 0 comma infinity such that the sum n equals to 1 to infinity 1 by fn is convergent. True or false? What do you think? Just apply the above theorem. We have uniform continuity, right, over open 0 comma infinity to open 0 comma infinity. There is r to r, so we can restrict that function to open 0 comma infinity, open 0 comma infinity, and apply the same argument. So since f is uniformly continuous on open 0 comma infinity to open 0 comma infinity, so there exists a comma b strictly greater 0 such that mod of f of x is less than a into mod x plus what, plus b, right? Now since since the codomain and the domain is positive, right, strictly greater, so we can remove this mod value. Okay, so this is f of x is less than ax plus b, right? Okay, now sorry, this is greater equals to 1 by 1x plus b, right? So take the summation n equal to 1 to infinity where x belongs to open 0 comma infinity. Oh, I think I'm not mentioning here. This is okay. Sorry, I'm not mentioning that time. Okay, for all x belongs to 0 comma infinity. Okay, now this is f of n is greater equals to summation n equal to 1 to infinity 1 by n plus b, right? Now this is a series and this is also a series. Now if we show this series is divergent, then we are done, right? Because by limit comparison test, if this series is divergent, then this series automatically, by limit comparison test, this series is divergent, then our statement is false, right? They says that this summation is convergent. So how you can show that this series is divergent? By limit comparison test you can show. Just take this. Okay, I'm doing, I will do that. Okay, let un, just take un equal to 1 by n plus b where summation un is blah blah blah, that thing. Okay, summation that thing. Okay, now now take vn equal to 1 by n. Okay, now un by vn is what? Un by vn equals to 1 by an plus b into n, that is 1 by a, right, as n tending to infinity. Okay, as n tending to infinity, this goes to 1 by e. Now by limit comparison test, summation un and summation vn converges and diverges together, but summation vn is divergent, right? Summation vn is what? Summation vn is summation 1 by n. This is divergent by p test. So summation vn is divergent. dgt implies summation un is divergent. This implies this series is divergent. Since this series is divergent, by comparison test this series is divergent. Therefore this implies summation 1 by fn as n equal to 1 to infinity is a divergent series, right? So we are done. So how we apply this theorem, you see, right? इस थ्योरम को अप्लाई करने के बाद ये क्वेश्चन कितना आसान हो गया, बट ये क्वेश्चन इन जनरल करना थोड़ा टफ है. इट इज नॉट वेरी इजी. Okay, now you can see the power of the theorem. Not theorem, it is a lemma. Power of the lemma. Okay, thank you. That's all for today.